Today's lesson, we are doing the same thing we did yesterday, except we are rotating around the y-axis this time. So this looks actually very similar to the function we saw in the picture yesterday, but this time when we flip it around the y-axis, the cylinders are facing a different way, of course. So we have these little dy's, these changes in y for the height, and the function needs to be in terms of y. So those are the two big differences. For our first example, I have this set up nicely for us. It's already in terms of y, and we've got our y bounds. Now that GeoGebra I showed you yesterday, I looked at it for this one, and the visual just really didn't help me much. So we're going to go ahead and do this one without that visual. Starting off, we're still using the volume of a cylinder. So I want you to write that down so you don't forget the pi. So we need pi times, we're doing this around the y-axis, so we need those y bounds on our integral. The radius is still the function itself, so we have e to the y squared, radius squared, and this time our height is our little changes in y, or the dy's. We can go ahead and square our e function before we integrate. We have e to the 2y. Now you can use u substitution on this one, just let u equal 2y, or you can think about this as undoing the chain rule as you integrate, which is how I'm going to do this one. So we have pi times, the integral of e is e itself. If we were taking the derivative of e to the 2y, we would multiply by 2. So when we integrate, we will divide by 2. And our bounds are 0 to 4. I can go ahead and pull that 1/2 out with the pi to just focus in on subbing 4 and 0 in. So e to the 8th minus e to the 0. E to the 0 gives me 1. So I can simplify this. I can distribute that pi over 2, but it really doesn't help simplify much. So I can also just leave this in factored form. Again, we just found the volume, so that's cubic units. Our second function, notice two things. One, this is a y equals, and we want to revolve it around the y-axis. In order to do that, we need a dy. So that means this function will have to be solved for x. So that'll be step 1. The second thing to notice is we don't have y bounds. So we need to figure out the y minimum and the y maximum for this one. All right, first things first, let's get this solved for x instead of y. I'm going to square both sides. And then what I'm going to do to get x alone is I'm going to add x to both sides because it's negative and subtract y squared at the same time. Saves me that step of dividing by a negative. Now we're going to take a look at this function on Desmos instead of GeoGebra because GeoGebra only allows us to put functions in that are solved for y, not solved for x. All right, so here's our function. We need to find our bounds for y. The lower bound for y, we're rotating it around the y-axis. So just this region, we can ignore the graph over here. Just this region is going to be rotated around the y-axis. So we can see our y minimum is -3 and our y maximum is 3. So now we have the bounds for our function. And then of course the little dy's will be our height. Volume of a cylinder. Subbing in the values. For our particular function, our bounds are -3 to 3. Our function is 9 minus y squared. We square the radius, and then the dy's are our height. This one, I want you guys to practice some of your algebra on this one as well. So before we integrate, we need to square that binomial. I believe I've talked through this shortcut with squaring binomials before, but just in case, as a reminder, you take the first term squared, so 9 squared. You multiply the two terms together, so -9y squared, and then double it, because you would get two of those terms when you do the distributive property, or foiling as most of you guys call it, and then you take the second term squared. Negative y squared is positive y to the fourth. Now we have this where we can integrate using our power rule. Integrating 81 with respect to y, adding 1 to the power, 18 divided by 3 gives us 6, and then adding 1 to the power and multiplying by the reciprocal, using those bounds of -3 to 3. Lost my y. I don't know if I didn't write it or if it didn't show up. All right. Subbing those y values in, 81 times 3 gives us 243. 3 cubed is 27, times 6 is 162. 3 to the 5th is 243, which is not divisible by 5. Minus, now we're going to get very similar values when we sub -3 in. So 81 times -3 would be -243. -3 cubed times -6 is +162. -3 to the 5th is -243. You can go ahead and use your calculator to simplify this. Again, I like the fraction answers, so use the fraction button because it gives you an exact value as opposed to the decimal, which is not an exact value. And we get 1296 pi over 5. We're talking about volume, so cubic units. Big thing on today's assignment will be solving those equations for x before you integrate and making sure you figure out what those y bounds are for your curve. As always, I'm here if you have any questions.